Hello everyone, this is my first video lecture and in this video lecture I will give a short introduction to the dimensional analysis. Firstly, before going toward the dimensional analysis, I will talk about physical quantities. All the quantities which are related to our physical world are known as physical quantities. Quantities such like mass, length, speed, acceleration, force, linear momentum, angular momentum, all the quantities which can be measured in our physical world are known as physical quantities. There are two types of physical quantities. Initially, there are fundamental quantities. And secondly, there are derived quantities. As the name suggests, fundamental one or the most basic one quantities are known as physical quantities. There are 7 basic fundamental quantities. There are only 7 basic fundamental quantities. First, there is mass. It is the most basic one. Second is length. Third one is time. Fourth one is number of substances. Fifth one is intensity of light. Sixth one is temperature. And seventh and last is current. These 7 quantities, mass, which is measured in kilogram, SI unit is kilogram, another units are also available. Second one is length, which is measured in the meters. Third one is time, which is measured in the seconds. Fourth one is number of substances. In physics, number of substances have an SI unit known as mole. Its SI unit is mole. If I talk that I have 1 mole of substance, then it means that I have 6.022 into 10 power 23 substance. Means 1 mole is equals to 6.022 into 10 power 23 substance, materials. Or it is a absolutely new unit, that's why I explaining this one. And fifth one is intensity of light, means how bright light is. Its SI unit is candela, CD, represented by CD. Sixth one is temperature, which is measured in the kelvins, SI. And seventh and last but not the least is current. Its SI unit is ampere. Now we will come toward the derived quantities. As their name suggests, derived quantities. Derived means they are derived from the fundamental quantities. Fundamental are quantities which cannot be derived from any other quantities, but derived quantities can be derived from the fundamental quantities. Except these 7 quantities, all the quantities come under derived quantities. Let's take an example. Speed. You have learnt that speed is equals to distance per unit time, means ratio of distance to the time is known as speed, means distance, or we can say length, and time means speed is derived by 2 fundamental quantities. First one is length, which is a fundamental quantity, and second one is time, which is also a fundamental quantity. And speed as derived from length and time is a derived quantity. Let's take another example. Acceleration. As you all know, acceleration is equals to rate of change of speed, or we can say that speed per unit time, means it is a ratio of speed to the time. It is acceleration, means speed, which is a derived quantity, time, which is a fundamental quantity, and from these two quantities acceleration is derived. Hence acceleration is in derived quantities. Third example, force, which is a product of mass and acceleration. Acceleration is a derived quantity, mass is a fundamental quantity, and force, as it is derived from these two quantities, first one is derived and second one is fundamental, hence force is also a derived quantity. In physics, except these seven quantities, all the quantities come under derived quantities, as I have already told you. Now we will learn about dimensions. The dictionary meaning of dimension is magnitude of something in a particular region. Means if there is a region and there are a number of things in that region, then the magnitude of a particular thing will be known as dimension of that thing in that region. But we are talking physics, in physics language. In physics, its meaning is power of variable, power of a particular variable in a particular unit. Means if there is an unit, if there is an SI unit, let it be of a speed meter per second, SI unit of speed, it is SI unit of speed. And we are talking about dimensions, then speed is a derived quantity derived with the help of length, whose SI unit is meter, and with the help of time, whose SI unit is second. It's -1 here. Then we can say that the magnitude of length or the dimension of length in the SI unit of speed have a power of 1. Therefore, dimension of length in the SI unit of speed is 1. And dimension of time in the SI unit of speed is -1, as second, which is SI unit of time, have a power of -1 in the SI unit of speed. You can relate these two definitions, means magnitude, the power of a particular variable in a particular unit, or the magnitude of something in a particular region, or these are definitions are interrelatable, means these are all about dimensions. Now we will move to our dimensional formula. A formula which will represent dimension of a particular quantity is known as dimensional formula. Dimensional formula is derived with the help of fundamental units. The most basic fundamental units are mass, length, and time. Dimensional formula for mass is represented with the help of capital M closed in square brackets. Dimensional formula for length is represented with the help of capital L closed in square brackets. Dimensional formula for time is represented by capital T closed in square brackets. There are 7 fundamental quantities, means there are 7 basic dimensional formula. The dimensional formula for other quantities can be derived with the help of dimensional formula of fundamental quantities. Let's take an example. We want to have a dimensional formula of speed. As you all know, speed is a distance per unit time. Distance, or we can say that length. Distance is a kind of length. Length have a dimensional formula for of L. Time have a dimensional formula for T. If we will take T in the numerator, then we can write the speed as L T minus 1. It is the dimensional formula for speed. You can also find dimensional formula for other quantities, like let me find the dimensional formula for acceleration. Acceleration is speed per unit time, ratio of speed to the time. Speed have a dimensional formula of Lt minus 1. Time have a dimensional formula of T. If we will take T in the numerator, then we can write it as Lt minus 2. This is the dimensional formula for acceleration. The major function properties of dimensional formula is that it is closed in the square brackets. If you will not close dimensional formula in a square bracket, your answer will be marked as a wrong answer. Let's take some another example. We have to find dimensional formula for force. Force, which is product of mass to the acceleration. Mass have a dimensional formula of m. Acceleration is have a dimensional formula of Lt minus 2. Then we can say that dimensional formula for force is mLt minus 2. This is the dimensional formula of force. And if we will talk about dimensions, as I have already explained you that what is dimension is, the power of a particular variable in a particular quantity is known as dimension. We can see that here mass have a power of 1, length have a power of 1, and time have a power of minus 2. Therefore dimensions of length is